Good morning, Final Year Project Committee. My name is Jermaine and I will be presenting on continuous learning roadmap for vehicle navigation and shortest path for third world countries. I will also be assisted in this presentation by Mr. Levar Simon and Mr. Carlson Wickham, who are the other members of this group presentation. Our presentation will take the following format. Continuous learning for navigation systems has attracted much attention. A key problem in this research is the difficulty drivers are faced with when navigating unmapped areas. Additionally, these systems are unable to learn new routes and predict shortest possible paths between two or more locations. Guyana, being a third world country with vast amount of undeveloped land, is becoming more and more populated with the advent of oil. New roads are now being built to allow the growing population to occupy land in areas that were previously unoccupied. With the development of these new areas, there does not exist a proper navigation system by which all newly built roads and streets are updated in the navigation system in a timely manner. Therefore, it will be difficult for drivers to get information on getting to a designated location of an unknown area. This project will allow these new roads to be added to an existing map and from there on out be able to determine the shortest path to a destination. Continuous learning using growing neural gas algorithm will allow for lifelong learning of a navigation system, mapping routes of unmapped locations, thereby allowing a user to choose the shortest route from point A to point B. The use of continuous learning using growing neural gas algorithm to improve navigation of vehicles would give confidence to drivers and passengers in getting from point A to point B in a safe, efficient, and effective manner. This can affect the time taken to arrive at a destination in an area that is not yet updated in current navigation systems. A study of this nature has the ability to provide significant information since it can inform users of the success and failure of continuous learning with the implementation of growing neural gas algorithm in navigation. It highlights the impact of continuous learning using growing neural gas algorithm, and it reviews how continuous learning with growing neural gas can impact the navigation system of vehicles. Neural gas is a type of artificial neural network inspired by the self-organizing map. Also a type of artificial neural network that is trained using unsupervised learning to produce a low-dimensional, typically two-dimensional, discretized representation of the input space of the training samples called a map. Bernd Fritzsche describes growing neural gas as an incremental network model that learns topological relations by using a Hebb-like learning rule. Unlike the neural gas, it has no parameters that change over time and is capable of continuous learning. Making a few alterations to Fritzsche's growing neural gas algorithm, Shilong Zhang and his colleagues were able to have a mobile robot equipped with sonar sensors, laser rangefinder cameras, a laptop, and GPS receivers map the campus of Hangzhou Jiangxi University. When it comes to shortest path algorithms, although Dijkstra shortest path algorithm is single source and single destination, it does not allow for negative edge weights. It has acceptable time and space complexities as compared to other shortest path algorithms such as Floyd-Warshall, Bellman-Ford, and Johnson. Now these are our research questions. To identify existing gaps in current technology being utilized in navigation systems of vehicles, to determine how continuous learning would improve the navigation system of vehicles and find the shortest path into rural countries like Guyana, and to determine the impact of a navigation system used by drivers to get from point A to point B.
The implementation of this research project is based on the growing neural gas algorithm by Bernd Fritzsche. Dijkstra's shortest path algorithm will be used to generate the shortest path to a selected destination. These algorithms will be implemented using Python programming language. As vehicles navigate new areas with new roads in Guyana, they would be able to generate a route map of these areas. Having generated the route map, the exclusive shortest path algorithm can be used to arrive at a destination located along any of these mapped roads. Python was chosen for the implementation because it is easy to learn, it is one of the most popular programming languages, and as such, there is a wide availability of libraries. The animation shows the growing neural gas algorithm in action. Given a list of nodes and the XY coordinates for each node, the nodes were plotted and connected by edges, eventually mapping out the route taken. The result seen here is after 10,000 iterations of the training function of the algorithm. As can be seen in the image, point A being the source and point B the destination, using the extreme shortest path algorithm, the shortest path to get to point B from A is highlighted in red. This image shows a different route that was mapped, and again the shortest path between points A and B is highlighted in red.
Research findings and results. To answer the research questions, questionnaires were distributed using a 4-point Likert rating scale which ranged from strongly agree to strongly disagree. Question 1. To determine the impact of a navigation system used by drivers to get from point A to point B. From the analysis, an overall mean response of 3.29 suggests that a navigation system can impact drivers positively to get from point A to point B. A standard deviation of 0.68 showed that drivers' responses deviated from the mean. 87% of the respondents agreed favorably that a navigation system has impacted their navigation route. Identify an existing gap in the current technology being utilized in the navigation system of the vehicle. A mean response of 3.03 suggests that the current technology being used by drivers for navigation has a gap. A standard deviation of 0.67 showed that responses given diverted from the mean. From a total of 161 responses, 131 positively agree that there is a gap in the technology being used, while 30 disagree. Question 3. To determine how continuous learning would improve navigation system of vehicle and find the shortest path in third world countries like Guyana. From the analysis, a mean response of 3.05 suggests that continuous learning would improve the navigation system that driver use to get to and from a destination using a shorter path. 72% of the respondents positively agree that continuous learning would improve the navigation system and find the shortest path. Limitations. It is imperative that the actual starting position of vehicle matches the starting position on the map. If not, the route map will be skewed. To obtain accurate latitude and longitude coordinates of the position of the vehicle at all times, the GPS receiver must communicate with at least 3 satellites. Communication with less than 3 satellites may yield inaccurate results. In this research, since it is only a proof of concept, the researchers did not take into consideration streets being one way. The researchers were unable to obtain a suitable GPS receiver to carry out physical testing. An Android smartphone with GPS logger installed was used to capture route coordinates. However, insufficient points were captured to give a true representation of the route taken.
In this project, we addressed the problem of continuous learning in navigation systems and finding the shortest path from point A to point B. The main contribution of our work is to highlight the concept of continuous learning with growing neural gas in navigation. The main focus of our thesis was on mapped areas, finding a destination within these areas using the shortest path algorithm. An approach based on growing neural gas algorithm was used for solving this navigation route problem. Its fundamentals rely on growing on-demand self-organizing neural network learning algorithm, an evolutionary computation paradigm that applies learning with the incorporation of Dijkstra's shortest path algorithm, which will be used to generate the shortest path to a selected destination as an important part of the navigating process. Our contribution in this part was to adapt these algorithms to an environment marking routes that were previously unmapped, which to our knowledge have never been addressed before. In particular, our concept can be taken into account our contribution can certainly be exploited in other environments with similar problems. Many different strategies can be adapted, but left for the future due to the lack of time. Future work concerns different approaches or mechanisms for navigation of vehicles in unmapped areas. This thesis has been mainly focused on the concept of continuous learning with growing neural gas in the navigation of routes in unmapped areas and finding the shortest path to a destination within these areas. Future work can be tested in the following areas. 1. It would be interesting for navigation systems to consider third world countries in their designs with respect to vehicle navigation equipment. 2. Utilizing unmanned vehicles to navigate through unmapped areas and finding the shortest path with a combination of marked and unmarked routes. These mechanisms would aid in distinguishing complex environments where individuals have no or little knowledge about the routes. 3. The way this concept model is constructed could be also changed. Instead of using the shortest path, it could be based on different factors to provide some information on the different routes to destination based on other attributes such as traffic.